Hello everyone. In this paper, we propose an end-to-end autonomous driving paradigm with temporal guidance from vehicles' ego states, METDrive. Typical imitation learning-based end-to-end autonomous driving models mainly rely on perception input such as camera images and LiDAR point clouds. However, such perception often includes a multitude of irrelevant objects that do not significantly contribute to the ego vehicle's motion planning. Consequently, the output of an end-to-end model that relies on the fused features from such perception may be adversely affected by the presence of such irrelevant detection. Here we show some examples of the models trained on image and LiDAR input only, where the vehicle's behavior could encounter failure even when the scenarios complied with the distribution of training data. In a case of ReasonNet, the perception was clear and simple while the vehicle got crashed despite the detected upcoming vehicle. In Transfuser++, a generated object appeared in front of the running vehicle on a highway but not in a blockage of the vehicle's path. However, the vehicle dramatically decreased its speed, leading to an extreme hazard. In another case, it was observed that the vehicle halted at the crossing despite the presence of a green traffic light and clear traffic conditions. An unreasonable stop also produced negative impacts on traffic flow and safety. To address this problem, we propose encoding additional modalities from the ego vehicle states to guide planning tasks in imitation learning-based end-to-end autonomous driving systems. Specifically, we treat sequences of steering, throttle, rotation angle, and waypoint vector inputs as time series data. The fused geometric and time series features then guide the waypoint prediction in our METDrive. Here is an illustrated pipeline of the paradigm with image and LiDAR point input only. In our METDrive, we propose time series data encoders for processing the ego-related states including rotation angle, steer signal, throttle signal, and waypoint vectors to guide the fusion of features from all the sensors. To clarify the lateral and longitudinal features for obtaining single-dimensional time series information, the temporal signals are decomposed into horizontal and vertical directions within the ego vehicle coordinate system for tokenization. Consequently, a temporal guidance loss is designed to optimize the consistency between the predictions of waypoints from adjacent time steps. Here we demonstrate our design in formulas. We evaluated the performance of our METDrive in CARLA longest 6 benchmark, achieving a driving score of 70%, route completion score of 94%, and infraction score of 0.78. In our demo, we want to demonstrate the effectiveness of our design. For the same scenario in CARLA Town 02, the baseline model speed output oscillated between 0 km/h and 22 km/h during the continuous frames, resulting in the jerks in driving. While our METDrive provided natural driving behavior with smooth speed output ranging from 7 km/h to 22 km/h without sudden jerks. In conclusion, targeting a common shortcoming in the existing end-to-end systems for the CARLA simulator, the absence of guidance from additional modalities, which may lead to failure cases in long-term tasks, we propose METDrive, an end-to-end autonomous driving paradigm with temporal guidance from ego states. By including the ego states, the model output was instructed compared to the baseline model's behavior based on the encoded time series features. In CARLA, we verified our design on longest 6 benchmark, achieving the driving score of 70%, route completion of 94%, and infraction score of 0.78. Thank you very much for your attention.